Warriors, I hope you are all well and having a good week so far. I am, and I'm better now that I am with you, sincerely. So let me get set up here so that we can get rocking. All is good in the hood. All right. All right. Looks like we got a pretty full house today. So cool. Let's see, so I can see all of you. All right, so here's where we are today. First prep session for our final. Our final right now is and going to be on the 14th of May. That's a week from Thursday. And the school exam schedule says 10:15 to 12:15. I think I can have it open until 12:45 because the next exam starting after that, I think, is like 2 or 1 or something like that. So that's my plan right now. Have it come open on Canvas assignments at 10:15 and close at 12:45. We talk some more about that. So here's where we are today. Map check. We're going to spend, here's how we're going to do today. I'm just going to do a very, very brief overview about the exam, the stuff that's on it, some points that come to mind. And then I'm going to talk about, we're going to kind of dive into descriptive statistics because we haven't been there in a while. And I'm hoping that'll come back to most of you pretty quickly. And then we'll pop back out of that and round up today with the kind of where do we go from here kind of thing. What are some of my recommendations on how you should and could prep? On Thursday, we'll do a We Drive called Joker's Wild. That's what I was doing just before class, is uploading that to your Canvas. So I'll talk more about Joker's Wild. But here today, or here on Thursday, we'll go over that in a We Drive format. So I'll have it up on the screen, and we'll go through that. On Friday, I'll have your classroom interaction and participation assessments posted, which leads me to talk to about all assessments to date are on Canvas. So that's all the Pearsons, the regression homeworks, those kind of things. So if you haven't checked Canvas lately, you probably want to do so to see where you stand, and any discussion you want to have beyond that, I welcome. So if you have questions, things like that, then please take a look at that and then engage me accordingly. Now, reading day reps, I'll talk about here in a sec. And then final exam, like I said, I'm going to have that open at least until 12:45 on Thursday the 14th. Okay, reading day reps, here's how we look right now. Plenty of spots open. That's the bottom line. So the only spot taken right now is 1 to 1:30. So if you want to get a piece of the action, get hold of me on email, stay after this call today, and just tell me at the end, hey, I'd like to grab this spot, whatever. Those are there for you. So here's what we're going to do today. We're already recording. We're going to talk about the basics on the final, talk about the hit list for the final. And then, like I said, I'm going to go through it and then come back to descriptive, and we'll talk about Joker's Wild and some strategies beyond that. So before we begin, do you have any questions, big or small, from anyone out there?
Is the final worth 20% of our grade?
So the final is going to be between 100 and 120 points. Offhand, okay. I don't know what percentage that is.
Okay, thank you.
Tim, did I answer that?
Mm-hmm. Yeah, I can just go look at the total points of the class and then figure it out.
Okay.
No problem.
And no one has asked me out of this question. No one has asked me this question out of this section, but in case it's on anybody's mind, to me, a point is a point. I don't weight some points differently than others. So if you earned a point of extra credit, that's the same value as a point on an exam, as the same value as a point on Pearson. Not to get off too much of a tangent. Well, we've been through how I assessed Pearson for that block too. So that's old news. Okay. Any other questions?
Is the final cumulative, or is it just based on block 3?
Yeah. So the final is cumulative. There's some points that I would look at more than others, and I'll talk about that. But the short answer is it's a cumulative final, comprehensive cumulative. Okay. Does that answer your question, Greg? Okay. Other questions, big or small? All right. So some basics about the final exam again, Thursday, the 14th of May, 10:15 to 12:45. At a minimum, I'm not going to post it any earlier than 10:15 because the exam schedule goes from 8 to 10 for the slot before that. So I don't want to put people in a situation where they're trying to hurry up on an exam just to get to this one or something like that. Like I said before, between 105 to 120. I don't think I would go any higher than 120. I don't think I would go any lower than 105. The exam is about 80% written right now, so I just need to kind of tweak up some things. Same method before, so it's going to appear on Canvas assignments. I finally got smart enough how to make it appear in multiple places, so if you punch into Canvas and look at the Canvas day, you'll be able to access it that way. Or if you go straight to assignments, you'll be able to assess it that way. It'll be in an Excel packet like you received it before. That doesn't mean that you have to do anything except enter your answers in Excel. You could theoretically do everything else on paper by hand if that's what you choose to do. So no deviation from our methods from last time. And in terms of access to me, that's what I meant by that comment. It'll be the same. I'll be standing by during your exam by telephone and email. I think that worked fine last time. Again, if you had kind of hiccups last time with uploading files with Excel, things like that, then you might want to get ahead of that. But really no deviation from the method we went for last time. So here's the hit list. Notice what I've got in bold. And so what do I mean by that? Well, because we've been over, and there's a lot to hypothesis testing, and we just went over regression, then I would, and I'll talk more about how I would approach this, but I would make sure that you're pretty solid there, or that you're so good at everything else that you can overcome any damage that you might take there. So there's two ways of approaching it. I would, you can pretty much bet that there's going to be something on there to do with regression and hypothesis testing. Beyond that, it's open season. It's a comprehensive final. So it's kind of like me saying, anyway, I know this probably doesn't help much, but I think some things we're going to do both today and Thursday will. I'm pretty confident about that. I'm going to come back to that. Just some points along the way. On sampling, remember the purpose of sampling, we're doing really one or two things, but most of the time with sampling, we have some knowledge about how the population is performing. The best example of sampling is in a production setting. So I work in a big factory, and I have been there for a while, and I know what our production mean is supposed to be like. And so I sample to verify that things are going the way that they should. Okay. That isn't, every example doesn't tie back to production, but just the fact that many do, that is pretty much the reason that I'm teaching this course, because I'm a supply chain guy. And so that's why, one of the reasons why supply chain folks teach this course is because we have a lot of examples with production that fall into sampling. Okay. Um, but again, when we're doing that check in accordance, we're talking about the probability of a sample mean or proportion, so that we can see if our process is behaving the way that it should be. And then we may have to determine a value of a sample mean or proportion based on probability. So again, we think, my production process is supposed to be performing at, let's say that I'm producing boxes, and my production process, my population process mean is that my boxes are supposed to be an average of 15 pounds apiece. Well, I don't have the time all day to check every box and weigh every single box. Um, I probably don't. And it would be very costly if I did that. But I probably could pull a couple boxes every hour and weigh those and take the average of those. And so, I want to have an idea in my head of what is the probability of what I should expect to see. So when I pull those boxes down and I weigh them and I average them, what is the probability that they should be between 14 and a half pounds and 15 and a half pounds? It depends on my standard deviation, obviously, but let's just say that I determine that probability is 70%. And then when I look at my sample average, I get something just way off. My sample average is something like 23 pounds. Well, the whole point of that exercise was, whoa, that 23 pounds is not something I should be seeing. It's just not very likely. It does have a likelihood, but we know that that likelihood is much smaller than in comparison to what I should be seeing. So based on that, I might make a decision to stop production. Wait a minute, these boxes are way too heavy. Something's going on. We're doing something wrong. Okay, so that really is the broad description of sampling. I have some idea of how the greater population is supposed to be performing, and I want to see how things are in my neck of the woods. Okay. Another example might be that based on all these national studies and research is population information about how much college students should be spending time studying during the week. And so, I obviously have to assume, I have to have trust. Sometimes when you get these global population figures, you kind of go, where did this thing come from? So you have to trust that a little bit. But then maybe I take a sample of you all and see, are we different than that? And based on that, I can, I might be able to do something with that, or I make the conclusion that we look a lot like that kind of thing. So that's the whole purpose of sampling. Um, and again, usually I sample because I don't have the time or the energy or the resources to count every single thing. If I could, then I would. So for example, with you all, I mean, there's, 23 of you, 24, whatever on any given day. If I really wanted to know something that wasn't invading your privacy, I could probably get it pretty easily, but that's not sampling. I already know that population because you all are a pretty small population. The populations we're talking about, it's either almost impossible to get all that information or it's nearly impossible. All the left-handed people in the world. Well, I would die trying to find that out. So I have to take a sample. So that's a little bit on sampling. Confidence intervals are kind of the opposite. Okay, so confidence intervals, and some of you did your Way of the Warrior projects on confidence intervals, which was super. Confidence intervals are more common when we are in a new situation, but we have a sample, sometimes by convenience, sometimes not, and we want to make an inference about the larger population. So, unlike the production example, where I'm supposed to know what these machines are capable of doing, I might have a new process or something new. Like I've said before, COVID and these days, there's so much that we don't know. So I'll bet that there's a lot of people much more smarter and powerful than me that are doing all sorts of confidence intervals, i.e., guesses and estimates about the greater population mean or proportion kind of what we're looking at. So, for example, things like known cases of COVID versus recovery versus death. There's probably all sorts of elaborate confidence intervals going on right there because folks are trying to figure out and make decisions on when we should go back to school, when we should go back to work, when we should do all of these things. And yeah, we don't have a greater population to refer to. Um, you could say, well, we could refer to the plague that happened, back in the 1910, 1900s. But, again, the data is limited and you have to make some assumptions there and people might not be comfortable making assumptions. But the bottom line is usually confidence intervals is where we either don't have access to the larger population or it's brand new. Okay. And that leads us to the second point on this slide, which is I just wrote identify when to use the T distribution and when not to. Okay. And the golden rule there is, do I know the population standard deviation? Do I know the population standard deviation? If I don't, of course, I have to be dealing and pursuing an estimate of the population mean in the first place. Okay, so if I'm pursuing an estimate for the population proportion, the amount of people that have quit working out, exercising since COVID. Well, if I'm pursuing something like that, then I'm going to use the Z distribution. Okay, because it's a proportion. But where I'm dealing with population means, things get tricky. And let's say that I'm pursuing the amount of time per week that people spend exercising since COVID and quarantine. Well, if I don't have an idea of the population standard deviation, and I probably don't in that instance, I'm going to use the T distribution. If for some reason I have an idea of what the population standard deviation is, which again is very difficult for me to visualize, but I would guess that it's some kind of expert who has commented on what they think the variation is and how that translates to a standard deviation, then I would use the Z distribution if that was given to me that way. Now, for you all, again, in the problems, I make it even easier. Read the problem. If the problem talks about a population standard deviation, then you're in a Z distribution situation. If the problem talks about a sample standard deviation, that's not the population standard deviation. Okay. So you need to put it over here. You're probably going to use it later, but don't mistakenly recognize the situation as something it's not. And then finally, write the confidence interval completely and correctly. So what's the difference? Completely means, and I'm just going to go to since we're here, let me go to my handy dandy pen. I think there was some residual chicken scratch. So, all right. So completely means that I don't want to end with something like this. Okay. So that is not correct or complete. Okay. This is kind of analogous to getting on the 20-yard line and taking a knee or something like that. And I understand if you run out of time, this is better than nothing. But if you've still got the gas, man, put the ball in the end zone. And so what I'm talking about is number one, this is obviously has to do with as I write it wrong, with a population mean because 155 is not a population proportion. Remember, population proportions are usually written in a decimal form. And even if they're not, we don't have 155% of the population. That's just not a thing, or the sample for that matter. So the centerpiece, first, I'm going to identify what's in the center. In this case, it's going to be my population mean. And I'm going to write greater than or equal to, greater than or equal to, and less than or equal to. And so I'm going to figure out, I'm going to do all my computations and add that to 155, and that value is going to go here. I know it's not, but I'm just going to pretend that that value is 170, something like that. And then I'm going to figure out the 155 minus all this, and I'm going to put it over here. Now, I'm going to talk more about on the exam because last time I kind of let it go, but this time I want to see the symbol and I want to see the appropriate signs. So I'll show you how to do it, or you can handwrite it. Either way, it's your choice. But this is what defines completely and correctly. Okay. Um, I suppose if you wanted to, you could write it out. So you could say the population mean is greater than or equal to 164.12 and is less than or equal to 170.12. I need to give you guidance on whether that's okay or not. And off the cuff, I would say, sure, if you write all that out. But if you're not going to write it all out, you need to write this out. Okay. That's completely incorrectly. All right. We'll keep on going. Okay. So this slide really is that slide that boils down the types of situations that you might find yourself in. And, I don't know how helpful this was to some of you. Starting left to right, framing, am I in a single value situation? And am I in a sampling situation? Am I in a confidence interval situation? And then once you're straight on the forest, working your way to the left to identify the situation, the tree that you're trying to deal with. Because out of all that falls a procedure and a formula. And I think for some folks, the more they do this, the less they need this slide. I think the less you do it, the less repetitions you have, probably the more you need this slide. Okay. After a while, you get to the point where it kind of becomes automatic. You recognize, you frame, you just keep on moving. And maybe at that point, to go back to this becomes kind of confusing. So it isn't a necessity by any means. I just put it here as a means to kind of take a whole bunch of information and put it in kind of a somewhat clear and concise framework to follow. Okay. But again, no, Michael Jordan he doesn't explain every step that's involved behind him dunking a ball. He probably couldn't at this point. I mean, even when he played, he probably couldn't because he's that good. The rest of us human beings sometimes need some frameworks, some how-to sheets, and that's what this slide is meant to do. But if it confuses you, then cease work, let's find another way to make this easier for you to get into and, drop science with defiance kind of thing. Hypothesis testing. So Greg asked me right off the bat, is this weighted? Is this cumulative? It's a cumulative final, but man, I would really know my hypothesis testing for sure. And I would certainly know my regression for sure. I think many of you regression was much more simple to you based on your final homework. That seemed pretty straightforward, and I would agree. So the name of the game with hypothesis testing, to me, the number one thing that I see takes down warriors is this: what's the null? What's the alternative? And so I have 2 bullets here on this. Let's go back to my pen. So I've tried to show you, and I've tried for us to go over multiple ways of setting up our null and our alternative hypotheses. Um, there's no one way to do it. The bottom line is that the null is associated with the status quo. And many times, more often than not, you're less interested in the status quo than something else that you're interested in. To avoid confirmation bias, and to just have credibility. I mean, if you're going to roll with hypothesis testing, you might as well roll with credibility. Otherwise, you can lose a lot of credibility. So to do all that, we have to first disprove and reject the status quo, the null hypothesis. Okay, so sometimes we can load our alternative, what we want to really, we believe is happening, we could load that first. There is some dangers with that technique, and that's if there's already an established status quo, we might not want to do that. Okay, but let's just talk about some things that are pretty much tried and true. The null is either going to contain a straight up equals sign with the alternative containing a not equal to. All right. So we're either going to have this or we're going to have some version of equal sign in the null. All right. So that is something that that's like a handhold, or I have a friend who's a firefighter, who he told me one time that they mark the hose. So in the dark, they don't get lost because they'll be in rooms fighting fires. And so they have, like, it's like reading Braille. He knows which way to go. In case he gets lost, he knows if he goes a certain way, he'll follow the hose out of the room, which I always thought was pretty cool. But the analogy here is that you have this safe place. You go, I'm trying to unscrew this null and alternative, and it's really confusing to me. But I know that it's either this arrangement or it's this, which is a little more complicated. But if I know that my null and alternative are either, hey, something is happening or it isn't, I can drop these in. And it's like that handhold on the fire hose. Okay, cool. I'm still in the middle of uncertainty, but I'm going the right direction. The other thing is that I'm going to have one value, okay, and it's going to be the same value, okay? So let's say, for example, that I'm dealing with some sort of population proportion, all right? That's connected to the status quo. Well, once I decide that that's that value, it's going to go down here as well. Okay, so these numbers will always be the same. They won't always be 0.76, but if the top one is 0.76, the bottom one will be. You won't have a case where one is 0.76 and the other is 0.75. And that's the scary part about loading the alternative first, is you might think that it's really 0.74, but if the status quo is 0.76, you need to park that 0.74 somewhere else, okay, and put it aside. That's a whole confirmation bias and avoiding that thing. Okay, so this is another handhold on the fire hose. You get that thing in there and good. Let's talk about a third handhold on the fire hose. So over here, in terms of our symbol, and I think I'm covering both of these at the same time, we're only going to have one of two options. We can either have the population mean or the proportion population. That's it. We're not going to see little p. Nope. We're not going to see X bar. Nope. We're not going to see little pump. I'm just kidding. Nope. All right. It's either going to be this or this. So once you figure out, oh, well, it's dealing with P-pop. This is a P-pop problem. You're just going to drop that in there. And just like those numbers, these are going to be the same. Okay. So really, I think this is tough for more people than not. Hopefully at this point, it's not tougher as it used to be than when we first started doing, but regardless, I would look for those handholds on the fire hose to drop those things in. Let's talk about this bad boy for a second. All right, so this is kind of messing with me. Well, the big thing here, if I'm in this situation, I've got to look at, these are going to be opposites. So what I draw in here with the blue is going to be opposite. So if this goes this way, that we think the population proportion is less than 0.76, then that's going to go that way, and vice versa. We will never, and we can say never, we will never have an equal sign of any sort in the null hypothesis, period. All right. So again, and when I say all this, identify the null and alternative hypothesis correctly, I'm talking about these values and this symbology. And then when I say write it correctly, I'm talking about these symbols as well as these. I guess it's all kind of the same thing. It's a little bit of redundancy there. Okay. But this is really, in my view, it's probably the hardest part about hypothesis testing. Is getting this right. Because if you don't get this right, you can do all the steps correctly, but you'll be trying to cram a square peg into a round hole, because you'll do something like reject the null, but it won't make sense. And so you'll kind of try to make it make sense, and it just doesn't go as well as you want it to. So spending the time to get comfortable on this is worth the time. And then this other part about interpreting the decision in the context of the problem and the situation. So again, what I mean there is that rejecting the null, all right, that's again on the brink of the end zone, but that's not the end zone. The end zone is, what do you do now? If you reject the null, usually it means that you can kind of continue headed in the direction that you wanted to head. So if I think that more people like hot dogs than hamburgers at the ball game, and I think that to a certain population, and I disprove the status quo, that supports my effort to sell whatever I was talking about, hamburgers or whichever one is of greater demand at the game. All right. So that means I should continue marketing. I should continue talking to people. I should continue selling. I should ask for a contract. I should do all those kind of things. I should ask for a trial period. I should do all that. If in that instance I fail to reject the null, it kind of means, hey, I had an idea, but I really don't have evidence to support that idea. So it literally means kind of status quo, kind of being stuck. So I think on hypothesis testing, a situation warriors might find themselves in that I've seen in the past is they get very focused on procedure, which is good, but then they lose sight of the bigger meaning. which is okay. So now that I've rejected the null, what do I do? What should I do? And what does it mean in the first place? Again, just because I rejected the null in this situation, like here, let's say I reject the null. So we find evidence that, or there's no evidence, there is evidence to believe that the population proportion has changed from 0.76. Well, I can make that statement, but I can't necessarily make the statement that it is now 0.74. Okay. All I did was reject the status quo. I can pursue this and I should, but there was no 0.74 in here. So I can't leap and say that this now is true. Okay. So some points to concentrate on hypothesis testing as well as all the science involved with it too. And this is one of these tables, just like the earlier one that I showed. Again, depending on who you are, this might be helpful or hurtful. If it's hurtful, stop. It's that whole, hey, doc, it hurts when I move my arm. Well, quit moving your arm. If it's hurtful to you and we just can't get it to help you, then quit, stop. If it's helpful to you, then keep using it. And it's just a framing thing. I'm working my way left or right. What kind of situation am I looking at? What kind of distribution do I need to use? And then from there on, really, it's just a procedural kind of thing. P-value, I get in some nuances there, and it's important to know the details. Okay, I'm not putting the details down, but if you're using the right details on the wrong problem, then you're going to get what you get. So, and then finally, regression. With regression, we want to examine the relationship between two variables, usually because we want to exploit that relationship. In sales and demand, we want to see, hey, if one thing is selling, what sells with it? We see this all the time in the marketplace. Amazon does this, iTunes does this, Spotify does this, so on and so forth. They do it with a lot more complicated and complex systems, but it all starts with this idea of regression. I think some of you might have struggled a little bit, and struggle is good. Don't get me wrong with, hey, what's independent and what's dependent variable on the final D3M homework. And with that, I would just, hey, look at the narrative, see. So if we're looking at like with the D3M homework, if we have epiphany and we have multiple places or multiple products or situations that we're comparing, well, then epiphany is most likely the independent variable because it's not changing. We're changing everything else to see what goes with it and what doesn't. So that's kind of a giveaway. And I don't know if anybody did these last two things. The last one I've kind of, to the point of getting a tattoo, I think I've kind of beat that drum pretty hard. But sometimes folks might confuse correlation with slope because sometimes those values look very similar, but they're not the same and they're not the same thing. So be careful about confusing those. So what I'm going to do now is jump back here to a descriptive review. And this Excel spreadsheet is on your Canvas today. And so I'm just going to go through this and prompt you every now and then to kind of help me out. And so I have two populations here. Dose pops, for some reason, this is just the way my kind of lack of brain works. I thought of the Dos Equis guy when I thought of the word dose pops, meaning two populations. This could be 12 applicants or 12 workers. Maybe we're running a human resources. Jennifer and I are trying to find people. We're trying to recruit people. Jennifer, and we'll just go with that example. So Jennifer has 12 people that'll take the job, and I have 12 people that'll take the job. And Cynthia, being the grand executive, kind of looks at IQ. All right. And she wants to make some decisions. She has a need for 12 people with higher IQ for some kind of skill-based work. And she feels that IQ is the solution. So these are all IQs. And we know that the average IQ is, I want to say 110 with a standard deviation of 15. That's kind of more Jackson Street knowledge at this point. We don't really care about that for the specific piece of the problem. So we'll say group Uno is Jennifer's group and group Dos is my group. And so what do I do with this stuff? Well, this right here is our friendly neighborhood frequency table. Okay. So first things first, when I say, hey, complete this frequency table, that's what I'm asking you to do. Now, at this point, from here on out, just to scaffold things or to delimit things or whatever the term is, I'm going to give you this framework right here when I ask you to do that. I'm going to give you the midpoints and all that, the group breakdown. Okay. And the reason for that is because there conceivably could be many ways to break these things into groups, and I'm just not interested in spending that much time grading. Okay. So I'm going to give this to you just like anything else. When I give you a submachine gun, you got to know how to use it or you might get hurt. All right. So to start out this frequency right here, this means how many folks are in that group from 100 to 109. Okay. So I'm just going to go down here and count 100. I got another one with 108. So that's a frequency of 2. Okay. Megan, what about where my cursor is right now? How many people are between 110 and 119?
2.
Okay. So that's 111 and 114. That is correct. That's 2. And I'm going to keep on going. So 120 to 129, that's these 3 right here. And then 133 or 130 to 139 are these 3. And then everybody above 140, I got 2 folks. So, Trent, what do I need to do now?
You have to add you have to total those up.
Okay.
And then you take the sum of those plus, you have to add it plus something to get the relative frequency.
Okay. So what I want to do is definitely add it. And I want to compare that 12 against this 12. Okay. I pulled up this version of this before, and all my numbers over here were, technical term, jacked up. And I was like, okay. And that's because this number did not add to that one right there. Okay. So that's what that check is for. We want to check ourselves before we wreck ourselves. So what we want to do now, let's see, Matt, what do I want to do now to determine that relative frequency there?
There's a formula, right? Rho freak or something.
I suppose. I mean, it's probably a lot simpler than you might think.
I can't remember right now.
Okay. Jack, what do you think?
I don't know.
Okay. George, what do you think?
You want to take each frequency, divided it by the total of 12.
Okay. So to get started, like George said, I'm just going to click on the one next to it. All right. And then I'm going to divide by that 12 right there. But I'm going to put dollar signs, as my son would say, cash, 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 around both sides. What's that's going to do is that's going to lock down that 12 so that I can do this right here. Tim, I see you laughing back there. All right. So that tells me the relative frequency, what that 2 is out of 12. And I can double check because I have 2s here. So those values should be the same. All good in the hood. All right. So for my cumulative frequency, I want to make sure these are lowest to highest, which they already are. They're already in all order. And in honesty, I always love it when people say in all honesty, because it implies that everything they said before when they just said that wasn't honest. But anyway, I'm already going to have this ordered for you. I'm not going to make you go through that drill on this. So to get my cumulative frequency started, I'm just going to carry that value over. Okay. And Tim, what do I need to do for this cell that I'm in right now?
So aren't you going to want to take the cumulative frequency from the top and then add the next one, add the 110 through 119 group as well, relative frequency?
Yeah, just like that. So they run kind of catty-cornered to each other. And that means that 33% of Jennifer's group had an IQ of 119 or below. Okay. So that's what that means. That's what cumulative frequency means. And I can drag this all the way down. Okay. And that golden one is my other cue that I did this correctly. Like I said, when I pulled up an old one, I think I had 0.937 right there. That's not going to be 1. So check it out. If this is 11, I mistakenly added, see, it's going to be off. All right. Or if this is 9, this is going to be all jacked up. But I put 12 there. Everything's happy. And it's not that 12 is a magic number. It's that 12 is the number of people in my population. Okay. So now I have all this nice and happy. My frequency table is complete. Now, if I ask you to pay attention to this part, because folks miss this. If I ask you to plot a frequency distribution, I am asking you to do what I'm about to do. When I plot the frequency distribution, I need 2 columns. Those 2 columns are the midpoints and the frequencies. They're right next to each other. Okay. If you plot the midpoints and the relative frequencies, I personally don't care because it's the same thing. Okay. Just be consistent. So if you roll with relative frequencies up here, then roll with relative frequencies down here. Okay. Because otherwise you're going to be comparing. It's not necessarily apples to oranges. It's like apples to, like, I don't know, pink lady apples or something, but might as well be the same. All right. So we're going to grab those 2. We're going to go up here to insert. We're going to go up here to connected scatter plot, and bam. All right. Now I got a whole bunch of space on the chart that I don't really need, but I'm going to police that up later. All right. Okay. So that is my frequency distribution for this data right here. All right. And all this should match up. This shows that, check it out, 50% of this population up here, so half, that should be 6, which it is between an IQ of 120 to 139. That isn't any magic statistical figure, okay? We can just observe that. So if I were to ask you, where's the highest concentration? Well, essentially this has a dual concentration. See what I mean? Because the highest number is 0.25, and that appears in 2 places. And the graph reflects that. Okay, and then we have some on both ends. All right. So let's check it out. Average here. All we're going to do is grab that array. And if I asked you to compute the median, you would do the same kind of thing, only you would say median. And you would grab all those numbers. And we always kind of want to glance at the median and the average. We see that the median is a little bit more than the average, but it's so small. I mean, 0.1, not even 0.1, it's like 0.9. So, we don't really have a whole lot of skewness going on. Now range, I'm going to combine, we could do a min. Remember, range is defined by the maximum value in the group minus the minimum. So you could just say 144 minus 100. I like to just stay in the habit of modeling. And I grab max of the array, not like Max Rubin, and then I grab minimum. And I'm going to go down the same thing. Okay, so I just did maybe some fancy stuff. Again, you could compute max in its own cell and minimum in its own cell and take the difference, or you could just eyeball it. So we have a range of 44. That means that from the top applicant, they had an IQ of 144 and the lowest was 100. That conveys now the variation of this group. And then standard deviation, because this is a population, I'm going to do SDevP, and I'm just going to highlight that same group right there. 13.24. Okay, again, it kind of means, and this is symmetrical, more or less, because the median and the average are just about the same. So we can say that 124 plus 13, so 124 plus 13 is like 137. And then 124 minus 13 is about 120, 121. That means the bulk of this population falls in those two values, which is what we already knew. Okay, so all this stuff lines up with itself. All right, it makes sense. That tells us about this group. You might be in a situation where you have one group and you want to compare another group. Okay, so Jennifer, now we know about Jennifer's group. Okay, so we can take a look at my group and we do the same thing. So in terms of frequency, we're just going to count, or we don't even need to do an equal. How many are between 100 and 109? That looks like those 4 folks. So that 4 would go there. How many are between 110 and 119? So it looks like those folks, which is 5. How many are between 120 and 129? There's no one in between 120 and 129, so that would be 0. How many are between 130 and 139? Same. As my son would say, same. So there's no one there. He says same about all the stuff he has no clue about. He's 9, man. Anyway, and the amount of folks that are over 140, and that is 3. And of course, I want to add these up to make sure I get what I should get, which is 12. So again, 12, and the amount of folks I have in a group is 12, so that's all cool. I'm going to use that 12 since I have it there. And again, the tendency, I made this mistake this morning, sometimes is you just want to go ahead and put 4 divided by 12. All right, now you have one calculation. All right, but the problem is you can't drag that anywhere, nor can you drag, like if you mistakenly put 4 divided by this, and even if you $sign that, you're just going to get that same value the whole way down. So if we drug this, well, that doesn't make any sense. Okay, and that's because you put that 4 up there. So we don't want to do that. All right, and of course we can do all this by hand, by calculator. There's nothing wrong with that, and there's nothing wrong with doing that on an exam if you choose to roll that way. I wouldn't advise it, but, I'll love you either way. All right, so I'm going to put my $signs right there, and I get that, and I'm going to drag on down. Okay, and then I'm going to do my cumulative frequency like I did up here. That first one's just going to carry over. My second one is going to be my catty-cornered sum, technical term. Now check it out already. Okay, so already Jennifer's like over there going, I got a smarter group than you, because look, 0.75, that means that 75% of my group is between 100 and 119. And I'm not even done compared with hers, where only 33% is between there. Okay. So we can already kind of do these comparisons on the fly. And then I'm going to drag on down. I'm going to get that beautiful 1. Notice that 0.75 means that I don't have anybody in those intermediate groups, which is reflected by my zeros. Okay. I do have 3 out here in this top group, and that's why my value changes from 0.75 to 1. Okay. So there's that. So again, if I used my midpoints and my frequencies up here versus my relative frequencies, then I want to do the same thing down here. So again, if I ask you, plot a frequency distribution, you can do it by hand if you want to. But regardless of the way you do it, that's the whole point of these midpoints. That's their sole purpose. Okay. So don't grab the groups, grab the midpoints. Go back up here, connected scatter plot, and bam. I don't know why these are so hard to see, but I'm not going to mess with that right now. Okay, now it worked out well that, let's just look at this real quick. Can I do this? Yeah. So I got to lose the Dos Equis guy, but he'll come back around. He always does. All right. So if I look at my x-axes, they both go to 160, and that's cool. I probably would want to get this white space. See all this white spaces here? I mean, if I was on the job, I definitely want to get rid of that, because all it is just, it doesn't need to be there. Folks who I'm going to show this to are going to get distracted with this, and it doesn't pop. So I'm going to get rid of that. But if you put this on the exam and leave it like this, I'm not really going to get too excited. I do think that you should be able to see things like this. So look at this x-axis here on the bottom, or y-axis, excuse me. It goes to 6. This one only goes to 3.5. So that we can't live with. Okay, so one of them's got to change. I'm just going to go ahead and change this one. So I'm going to go over here and try that. And that looks like it did the trick. All right. So now, we do this over here. So we get our average the same way. Got to be able to spell it to do it. I'm going to grab these folks. Make sure I'm on the page. My median. It's going too fast. Cool. My range. I'm going to combine it all, max versus min. By looking at it, I know that my range is going to be 50. So let's see if Excel treats me right. Not if I don't tell it what to do. And standard deviation. Again, if I choose population up there, up top, I should use population down here. And these folks aren't random. We put them through, a hiring process and all that stuff. So they're really not random. Okay. So what? I have all these descriptive statistics about these different populations. I have these graphs. Now it's a matter of how do we interpret this data? Okay. So you kind of got to know what's the context. Remember, Cynthia, we said once the higher IQ group as a whole. Okay. So there's a number of ways we could look at that. One is we could start with this average and compare averages. So Jennifer's group is at an average of 123.9. Mine is an average of 118.5. So based off of that, the indication is that Jennifer has the higher IQ group. Okay, let's just confirm the shot group. Well, Jennifer's median is pretty much what her average is. So there's not a whole lot of skew there. There's not one smart dude or dudette in the group that's pulling the group average higher than what it should be. However, look at mine. My average is 118, but my median is 114.5. And you might say, well, it's 4 points. Is that really a big deal? Well, it's more than the difference between Jennifer's average and median. So let me look. Well, wait a second here. When I look at my frequency table, like I said, 75%, 3/4 of mine are between 119 and 100 versus Jennifer's almost 66% of hers is higher than 120. Okay. And why is that? Well, that's exacerbated because these three folks right here, it turns out they're my lifelong friends and I paid them money. All right. I'm just making that part up. But the point is, once you take those three out, look at the rest of my distribution. It reflects that. Okay. I have a lot more variance in mine than she does. So what does that mean? Well, that means, IQ is IQ. It's one method of intelligence assessment. But if we gave them other batteries of assessment, we'd probably see the same kind of spread of scores. They'd probably be pretty consistent. Okay. And depending on what Cynthia needs these people for, she's probably going to select this group. She's not going to select mine. Because number one, my group doesn't have the tendency that she's looking for. And number two, my group has more variation. So if anything, my group will perform more inconsistently. Of course, if we took these three folks out, they'd probably be very consistent. Once we did a standard deviation of these folks, 1 through 9, their standard deviation would probably be even lower. But it doesn't really matter, because these folks are in a higher range anyway, if you look at this concentration here. So what are the procedures for interpretation? Well, there's no hard and fast procedures for interpretation. What I would recommend is everything that we've done today on this screen, you feel very, very comfortable with. Okay, so that when we do it, it's kind of like just getting up in the morning and brushing your teeth. You're not even thinking yet. You're just going through the normal thing. And then once you've got all that in front of you, so you don't waste I don't want to say waste, you don't expend your energy going, okay, how do I do this number again? Well, what you want to spend your brain power on is, what does all this mean? Okay. And how do I get depth to my interpretation? So when I say depth, how can I use more than just a single statistic to make my case? And when I say make my case, we're not making a sale. The numbers shouldn't lie. They should tell us how we should interpret. Okay. So you shouldn't have to feel like you're stretching. If you know what you're looking for, look for things like tendency, look for variation. Think about what tendency means. Tendency means just that, how a group tends to perform, how they tend to act, how they tend to be. Tendency is not probability, how they tend to score. Okay. And then variation talks a little bit about their consistency. If there's wide variation and we don't have something obvious like this, then depending on what we want, but most of the time we don't like variation. Variation is not variety. Okay. Variation means more often than not, less consistency in performance. The wider spread, the more inconsistency. If Cynthia's like, I need these folks to do high-powered things every day, she doesn't want one day where they're having a bad day as a group, because that may be lost money. Okay, so that's an example of where we wouldn't want variation. And I think in business, more often than not, we don't want variation. Okay, so, but the bottom line is I would encourage you to get very comfortable with everything we just did procedurally so that you know, and what is the distribution? I don't know. 25% of your energy constructing this so that you can spend 75% of your energy interpreting it. That's probably not a bad goal. That's probably not a bad goal, especially if interpreting is a weakness that you have. What you don't want to do is get sidetracked and how did I get this to be one again and those kind of things. That's just depleting your energy of all that interpretive skills. Okay. Questions on anything that we did right here, big or small? Anything at all? Okay. It's not a one-time question, so if you think of something later, we haven't touched this in a little while. I wanted everybody to get refreshed on terms. It's not the last time we're going to talk about this kind of stuff in between now and the exam. So if you're like, then don't worry about it. We're going to talk about some more. Okay, one more thing I want to talk about before we part ways, and that is to go back to here. Two more things. I'm sorry. So this is the first one. And what am I looking on time? Okay, we're good. All right. So I get asked this question more often than not. How do I prep? Okay. So here's some thoughts that come to mind. So here we are today. The first thing I think you need to do, and I think the first two things shouldn't take you more than like 10 minutes. The first thing is, where are you at in terms of your quote grade in this course, and what do you want it to be? That's the assess and decide. And how much effort and work do you need to put in, and how much are you willing to put in? Those are all individual decisions. I don't have any judgment associated with that. I don't like talking about grades, but I do because they're important to you. To me, it's about the knowledge. And you could ask these questions in the same way. If you're like, hey, where am I at with the knowledge, and how much more do I want to learn, and what am I willing to put into that? Those are questions that are going to help you decide how much time you need to spend between now and next Thursday. Okay. Combined with your personal priorities, work, school, interests, Ozark on Netflix, and all that other stuff. All right. And I know you're like, hey, I don't need you to tell me that, Jack, but okay, I got it. The second thing is, where are you strong and where are you weak? Okay. And I say initially and continually. So when I say initially, you can ask that question today. Tomorrow, it may be different. Okay. So I don't want you to think that you get this answer of I'm strong on this, I'm weak on this today, because you should continually assess as you get more reps in and you keep working. Okay. So I think those first two things would take you about 10 minutes. I wouldn't spend much more time on it than that, because you intuitively know those answers already. You might want to put them on a piece of paper or something like that if you really want to get calibrated. Number 3, organize for combat. So here, this is going to take you a little bit more time depending on what you've kept and saved. So what I'm talking about now is I'm talking about prepping for combat. I'm talking about getting your formulas, at least organized, straight. I'm not talking about getting consumed with that, but I'm just, starting to get all your tools ready so that you can reach out and grab them as you continue to prep. Okay. If you just start jumping into prepping and you're not going to start organizing your formulas until 4 days from now, that just seems counterproductive to me. Okay. Attack Joker's Wild sooner than later. What is Joker's Wild? Joker's Wild is this that's on your canvas today. And this is what we're going to do on Thursday. So there's a little bit of intro, just a real general one. There's a little bit of backstory, but then here we get right into it. Okay. So on Thursday, this is going to be up on the screen, and I'm going to, go around the horn. Hey, Brianna, help us do this part. Hey, Lexi, help us do this part, so on and so forth. There's no requirement. There's nothing for you to turn in. Okay. We're done with that. So how much prep you put in I recommend that you grab this as soon as you can and you have time and you rep out with this thing. I recommend you do the whole thing. And you might think, well, why should I bother with that? We're going to do it collectively on Thursday. Well, because, okay. So there's 5 sections to this. It's your choice. You could do nothing with this, or you could do all of it, or somewhere in between. Or based on your assessment, you might look at the problems and say, hey, I'm going to go to this one. What's behind door number 3? Or I'm going to go to this one, quarantine. Okay, so on and so forth. But this is on your canvas today. We're going to do this whole thing on Thursday. That's the Joker's Wild We Drive. Okay, but I would attack that sooner than later. Along the way, identify and send questions. Send them to your fellow warriors. Send them to me. Hey, I'm doing this and I'm just lost in the sauce, or this doesn't make sense to me, big or small, earlier than later. The earlier we identify that you've got a question, the earlier we can answer it, and the stronger you can get. Selectively attack practice packs, and I'm going to set up some practice Pearson. Remember, practice Pearson doesn't count for anything except your knowledge and prowess. But just because you go into Pearson and miss a whole bunch of stuff on practice, I'm not looking at that. I'm not counting it. The only reason I would look at it is if you ask me for help, I might look and say, okay, where did you make mistakes? But as far as pulling a number out of there and putting it towards your current totals, that is not what that's about. Also, what I didn't put up here between the question part is grab some reading day rep time. I mean, if that's what you need and will help you, the shame would be that Friday passes and you're deep into the weekend and you're going, man, I really need some help. Even then, I'll help you. Okay. I'm not saying, hey, after this day, I'm not helping you or whatever. Reading day might be a great time to do it, though. Along the way, I would keep track of repetitions. So when you do your assessment and you say, hey, this area I have is a weakness and I'm going to do something about it, I would keep track of how many problems you have invested in that area. And because the point is just going and grabbing a barbell and doing repetitions and not counting them and not thinking about how they're going. That's what suckers do. None of you guys are suckers. The pros say, hey, I've done 5 reps here and I'm still not getting it. So maybe I need some more help on what I'm not getting. Or I've done 6 reps here and my first 2 were really bad, but my last 4 have really been badass kind of thing. All right. And then maybe you conduct some time trials. So what do I mean? I mean that you continue to put constraints on yourself. And so you get a practice problem or something like that. And you say, hey, I'm not just going to do this and take as long as I need to do it. I'm going to put 10 minutes on the clock. I'm going to put 15 minutes on the clock. I'm going to put whatever on the clock. And I'm going to see if I can get this done correctly in that amount of time. I wouldn't jump to a time trial right off the bat. But if you're pretty far along with this thing, why not? Why not constrain yourself with a little bit of time? Because on the exam, and it's not just about the exam, but that's what we're talking about today, you are going to be constrained somewhat by time. You won't have all the time in the world. And so at some point, you do need to bring time into your assessment of yourself and your ability to work with this knowledge. So this is on the final slide of the slide deck that's on your canvas today. And again, those are just kind of my recommendations on how I would approach this. And I do see this slide here as a hierarchy. So it's not a shopping list. It's not I'm going to go down here and do this first. I would not recommend that you do something down here unless you have kind of worked through it. Okay. I think the Joker's Wild is the best kind of comprehensive prep that I could give to you. And I will give you the solution later in the week so that you've got that as well. So if you rush off to a practice pack without spending any time in the Joker's Wild, I would really just caution against that. I would really just kind of say, hey, that probably is not the most effective way to proceed. Okay. Any questions from anyone before we break for today? All right, super. I will stay on till we clear the call. It's good to see you all. Keep your spirits up. And if I don't talk to you in one way or another, I will see you on Thursday. Take care.
Thank you.
Thank you.
Thank you.
Actually, I did have a question.
Okay, what's up?
Let me figure out. It was actually about the homework, about trying to figure out what variable is X and what variable is Y. Because I think I did it and I got them mixed up somehow.
Yeah. So, again, Thomas, you want to look for those things where we would see what's dependent on what. And the fact that we have Epiphany and we are trying to see what other products it goes with. So we're trying to match, I think, Epiphany with one setting, how it did at one setting and how it did at another setting. So there we're saying the success at the setting is dependent on the variable itself, because the variables, Epiphany is not changing. We're keeping it constant. And whenever we keep a variable constant, that's the next best thing, or not the next best thing. That's another way almost of saying, for now, we're assuming this variable is independent and these other things do change. And so therefore they are dependent on that other variable. But beyond that, beyond the homework, I would say that, you just gotta look in the narrative, look for some things that, the easy takedowns, like, are we talking about weather? Are we talking about time? Those kind of things. And the narrative might just say that we have reason to believe that, the amount of traffic accidents are dependent on holidays, for example. So if it's explicitly stated in the narrative, we kind of want to definitely cue into that. Does that help?
Yeah, kind of, because I redid everything last time and I switched my X and Y up. I'm trying to figure out what I put where. Because I think the first time I did it, I used like the 3D, the laser tag and stuff as my Y, and left the Epiphany as my X.
Right. That sounds like the right thing to do. I didn't look at your work itself. I mean, do I have your work?
When I submitted it, I had all my work on the page that kind of had the work with the answer sheet.
Okay. Well, I'll see if I can pull it down and see maybe what you did. Maybe it wasn't a matter of confusing X and Y. Maybe it was something else.
Yeah.
I don't know if I got it right, but I used Epiphany as the Y. If you have like an answer to compare it to.
I
Yeah.
used Epiphany as X and then Y as like the 3D laser gaming and stuff like that.
Yeah. So let's see here. Since everybody's here.
I noticed it didn't change when I switched them though. Is that like true?
Yeah, I was confused on which one I should put as X and Y, so I kept on switching them and I got the exact same answer either way.
Yeah, same. All right.
Well, it depends on what we're talking about. If we're talking about the slope of a line, it will change.
Yeah. Yeah, because I got different numbers for both sets. The only number I got the same was R. Like no matter what I did for R and X and Y, that was the same for both sets.
That's what. Yeah, same.
Yeah, that's
Yeah.
what we're talking about. Is
For slope though, I didn't test it.
Yeah, R, it doesn't matter. You can enter, it's the one that it doesn't matter. So you can, it doesn't matter which one you grab first. I don't want that one. Hang on 1 second. Yeah, that was the one I wanted. All right, so all right, Thomas, you still there?
Yeah, I'm still here.
Okay, so let's see here.
Yeah, because those that you have down at the bottom was the second set I did, which I think I did Epiphany as a. Let me see what I got here.
Yeah,
Whoops.
so Epiphany is the dependent variable because we're changing the situation. So we're assuming that the drink sales are dependent on the situation that we sell them in.
Yeah, because the answers I submitted, like for the first 3D, was like 3,471, and then I just switched my X and Y, and then I got the 102.99. Whoops.
Yeah.
Uh-oh.
Cynthia, I think you might have done the same thing.
Yeah, I did the exact same thing that he just said.
Yep.
Because like the numbers were like a little bit wild, and I was like, well, I don't know if this is right. So, but then I redid it second time, and they kind of like correlated a little better, where you can kind of like, okay, I kind of see what's going on.
So would all I need to switch technically would be the 3D laser tag, and the gaming and classic would be the X, and then Epiphany is Y.
Yep.
Yeah, but you would need a new slope and intercept too, so you'd have to figure all that out and then do it that way.
Yeah.
And it'll indicate in the directions if there's not if it's just 3D and Epiphany in one problem, it would indicate like which one is we're changing or basing it off of, right?
Yeah. So I'm trying to pull up.
Yeah, because it just says like number 6 is like what is the actually I got number 10. Using a regression model is 3D ticket sales were 800. What would be the predicted amount of Epiphany sales? And then all the questions just go and have you like list like laser tag, and then you like multiply it by 800.
Well, so when a question, I mean, really, I'm just having a hard time pulling up the narrative where it's hidden here somewhere. Maybe not. Time to get a new computer. I do not know why I can't pull up this document. There you are. Okay. It's like watching paint dry. Come on. It's mad at me because I hit that so many times. Okay, here we go. Okay, so we're down here.
It should be like number 10, I think, is where it starts.
Yeah, it's like 10 through 15.
Okay. Dominic is also trying to determine the most lucrative match for Epiphany. Over the last 2 months, he has had the opportunity to sell Epiphany at 4 different events. Blah, blah, blah. His sales data is in the table below. All right. And then a description of what this means. So using a regression model, if 3D ticket sales were 800, well, essentially it's giving you the X value. I mean, that's to me, this, it's saying if 3D if it was 800, so it's giving you the X and asking you for the Y.
Mm. See, I think the first time I looked at it, I just assumed Epiphany was the X because like that was the same consistent thing through the whole question.
That's the same reason why I thought that. I thought that was like the independent. It doesn't change, but.
Well, I mean, the thing is that, I mean, I think it's an honest mistake. I mean, we can have variables that sometimes are dependent and sometimes are independent. Here, time is independent. I mean, I think that's pretty clear. So Epiphany is dependent on time. So Epiphany is a dependent variable up here. Our time is X, and Epiphany sales are Y. Does that mean Epiphany is always dependent on something? Well, I think in the larger context of the problem is, we're trying to decide some things about Epiphany based on other knowledge that we have, whether it's time or other events. So when we say we're trying to decide something based on other knowledge, that is another way of saying that we're trying, the stuff we have is dependent on the other knowledge.
And then dependent is the Y, correct?
That is correct.
Okay.
So, here, what would be the predicted amount of Epiphany sales? Again, we have a value for 3D or laser tag or gaming or whatever, and we're predicting off of that amount, which is another way of saying it's dependent, because and we're assuming that dependency because otherwise we wouldn't be predicting. Not for Epiphany, we would be doing the reverse. So if Epiphany was independent, we would be predicting the 3D ticket sales or the laser tag ticket sales or whatever. But because Epiphany is dependent on these things, that's why we're able to predict the amount of sales. We're assuming that there is a dependency. So I mean, I think that, I would say just let that sink in. I mean, I don't know. Does that help? Do you feel like the problem?
Yeah, I think like
is
once I
confusing?
reread it after your feedback, it kind of helped. Because originally I might have not like really like I read the question, but I didn't understand it, and I just looked at like, oh, Epiphany is like X, because that's like, it was kind of the same. And then I redid my numbers last night, and I'm kind of I did it right the second time, so I think I just like flip flopped them.
Yeah, I mean, I guess I hesitate to say I wouldn't read too much into it. I mean, I would just think about, I don't know.
Yeah, I got it now. I got all the answers and like changed my slope and stuff like that, so it works for me.
Okay, cool.
And also, I saw that you had a slot for a reading day for that Friday at 1 to 1:30. Can I take that?
That's actually the one time that I don't have.
Okay, well, what time do you have?
I have every other time. So let me see here.
Can I do 1:30 to 2 then?
Yeah.
All right.
Let's see here. I'm not going to share the screen again, so I'm blocking that in. 1:30 to 2. So I'll send you a Zoom invite, Cynthia, after this.
Okay, that sounds good.
And we'll do that 1:30 to 2 on this Friday. Okay, cool.
All
What
right,
else?
thank you.
Yep, you bet.
I just stayed on because I had something cool I wanted to. I read something about like data bias right now, and then found like a cool book, so I figured I'd shoot it by you rather than
Yeah,
get an email on it. It was where's the link to it? I just had it up.
I'm gonna get out of here. Thank you for your help.
all right, Thomas, take care.
Yep, thanks.
I figured you would find it like interesting. But it was an article from Melinda Gates. And then I looked more into it, and there was a book that came out recently about this. And it's just how like simple things like they're not asking the right questions, or simply a lot of the studies do not involve women. And a lot of the information that we get involves the head of the household, which tends to be the man. And so they're finding that more and more there's a lot of data bias in something that doesn't seem to be something that should have any bias.
Yeah,
So,
yeah,
I found it to be cool. Figured I'll run it by you.
yeah. Send me that link. Can you do that, Max?
Yeah, it's in here. Do you want me to email it to you though? Because I just put it in the chat.
Oh, you did?
Yeah.
Got it. I got it.
And then I
is-
think
is
the
it a book
article.
or-
This one's a book.
Okay.
The article I started reading on because I found that a while ago, but then it was just going through their blog. I found a 2019 year, like 29, looking back at 2018, they wrote like this thing. And it was like one of the things they found was number